Dear students, myself Dr. Ganesh Acharya, Assistant Professor, Department of Chemistry, IDSC Government College, Chikmagaluru. Today I am going to discuss about your physical chemistry part of syllabus given by the Kuvempu University. That is third semester syllabus of BSc of Kuvempu University. In this part, I am going to discuss on the chemical kinetics, which is a part of Unit 4 of physical chemistry. Now let us have a look at the syllabus allotted for you in the physical chemistry part, that is chapter 1, in which we will have discussions on chemical kinetics and catalysis. It is of 8 hours syllabus and 11 marks weightage in the theory examination. So it includes the review on the rate, order, molecularity, comparison of order and molecularity, derivation of expression for reaction rate constants of second order reaction with A is equal to B and A not equal to B, and theories of reaction rates and experimental determination of kinetics of inversion of cane sugar by polarimetric method, and catalysis, where we are going to have the different types of catalysis and characteristics of catalytic reactions, and theories of catalysis and enzyme catalysis. And remember, there is also one more chapter, that is chapter 2, which will be electrochemistry. We will have a discussion on that in the coming classes. Now my presentation today, it includes the following terms, that is review of the terms rate, order and molecularity, comparison between order and molecularity, derivation of expression for rate constant, that is where two reactants are same, that is A is equal to B. Okay, now let us see what is actually chemical kinetics means. Chemical kinetics is actually the branch of physical chemistry which deals with rate of reactions. So it is a branch of physical chemistry dealing with rate of reactions, that is called as chemical kinetics. It also includes rate of reactions, rate laws, and factors affecting reaction rates and mechanism or steps involved in the reactions. So this is about a brief introduction about what is chemical kinetics. Now let us see what is meant by reaction rate. Let us have a reaction where a reactant A gives rise to a product B in a simple reaction. Okay, so A is reactant, B is product. Now obviously with the time what happens? Concentration of A must decrease, so it can be given with a negative sign, and concentration of B must increase, so obviously it can be given with a positive sign. So rate of reaction can be defined as the change in concentration of reactant or product with the time. So it is the change in concentration of reactant or product with time. So therefore when you consider A, rate may be minus dA by dt. When you consider product B, it will be plus dB by dt. The square brackets always represents the concentrations in mole per dm cube. Okay, and D means what? A small change in concentrations with the time t. Okay, so rate of reaction rate means change in concentration of reactant or product with the time. And now let us see what is rate law. Rate law means, so when you have a reaction, say a reactant A gives a product. Okay, now if the concentration of reactant A is raised to some power, say n, then according to rate law equation, rate of reaction is directly proportional to reaction concentration raised to some power. So that is called as rate law. So what is rate law then? It is the rate of reaction is directly proportional to the concentration terms raised to some powers. So in the case of a reaction where A gives rise to product, then rate is proportional to A to the power n, or rate is equal to K into A to the power n. So the expressions shows how the reaction rate is related to concentrations in the rate law equation. Okay, so according to rate law, rate of reaction is proportional to concentration of reactants raised to some powers. And then what is order of reaction? Order of reaction is nothing but it is a sum of powers of concentrations involved in the rate law equation. Sum of powers of concentrations involved in the rate law equation. Say for example, if there are two reactants A and B reacting to give a product, then the rate law equation gives rate is equal to K into A to the power m, that is concentration of A raised to m and concentration of B raised to n. Then according to the definition of order of reaction, it is a sum of powers of concentrations of A and B, that is m plus n. So rate of reaction, order of reaction is a sum of powers of concentration terms involved in a rate law equation. If m plus n is equal to 1, then it is first order reaction. Say for example, in case of a reaction involving N2O5, rate is proportional to concentration of N2O5 to the power 1. Then order should be 1. If there is a reaction between hydrogen and iodine to form hydrogen iodide, as rate is equal to K into concentration of H2 to the power 1 into concentration of I2 to the power 1. So here sum of powers means 1 plus 1 is equal to 2. So therefore it is a second order reaction. If m plus n is equal to 3, then it is a third order reaction. So this is about a simple definition and of order of reaction and few examples for order of reactions. Now let us see what is molecularity of a reaction. What is molecularity? You can have several types of reaction. Obviously, maybe elementary reactions or simple reactions or complex reactions. In all these cases, there must be some reacting molecules involved in the reaction. So, molecularity of any reaction may be the total number of reacting molecules involved in a reaction. If there is one molecule involved in the reaction, then it is unimolecular. If there are two reacting molecules, then it is bimolecular. Then if there are three reacting molecules, it is termolecular reaction. So molecularity is the number of reacting molecules or total number of reacting molecules involved in a reaction. What are the differences between order and molecularity? By the definition of order, it is sum of powers of concentration terms involved in a rate law equation. Molecularity means total number of reacting molecules. So order can be experimentally determined, but molecularity is a theoretical value. And order can be fraction. It may be 0.5, 1.5, 1.25, etc. But molecularity must be a whole number because you cannot have half a molecule, one third of a molecule, etc. You must have a whole number. So therefore, order can be fraction. Molecularity must be whole number. Sometimes order can be zero also, but molecularity cannot be zero. And order of reaction may be sometimes changing with some of the parameters like pressure, temperature, concentration, catalyst, etc. But molecularity must be invariant. It will not change. The number of molecules cannot change. Okay. So these are some of the differences between order and molecularity. Now Let us discuss about the expressions for rate constant of second order reaction. Obviously, there are two types of second order reaction. One where the two reactants are same, and the other one is the two reactants are different. Okay. Now let us look at the first type of reaction where two reactants are same. Let us consider a reaction where two reactants, say capital A plus capital B, gives to product. That is, here two reactants are same, both of them are A. Therefore, 2A gives rise to products. Let the initial concentration of the reactant A is small a mole per dm cube. So what will be the concentration of product formed at time t? 0. Right? Say after some time, what happens after some time t? Say the initial concentration of A, that is small a, may be changed to some x moles of A, which will be reacted. So out of small a, x moles is reacted. So therefore the remaining concentration of capital A after time t must be A minus x, right? So by the rate law equation, dx by dt is proportional to a to the power 2, that is capital A to the power 2, because it is a second order reaction. The power of concentration should be 2. So after time t, concentration of A, capital A, is how much? A minus x. So therefore dx by dt, that is rate of reaction, is proportional to A minus x whole square, or dx by dt is equal to k into A minus x whole square. That is equation 1. So when you reorganize equation 1, you will have dx by A minus x whole square is equal to k into dt. So from equation 2, you can get the expression for rate constant k upon integration of equation 2. So that gives integration of dx by A minus x whole square is equal to k into integration of dt. What is integration of dx by A minus x whole square? That is 1 divided by A minus x. What is integration of dt? That is t. So therefore you will have 1 by A minus x is equal to kt plus an integration constant c. Okay. Now you know that at initial time t is equal to 0, obviously x is equal to 0. So in equation, what happens to c? As t is equal to 0, x is equal to 0, c must be equal to 1 by a. Now if you substitute for c is equal to 1 divided by a in equation 3, you will get 1 divided by a minus x is equal to kt plus, so what is c? C is 1 divided by a. So 1 divided by a minus x is equal to kt plus 1 divided by a. So this is not dx by a minus x, this should be 1 divided by a minus x is equal to kt plus 1 divided by a. So when you take 1 divided by a to the left hand side, what you will have? 1 divided by a minus x minus of 1 divided by a. So therefore when you reorganize this equation, you will have k is equal to 1 divided by t into x divided by a into a minus x. So this is equation 4, and this is called as expression for rate constant k of a second order reaction when two reactants are same, that is a is equal to b. So k is equal to 1 divided by t into x divided by a into a minus x is the expression for reaction rate constant of second order reaction when two reactants are same, that is a is equal to b. So dear students, let us stop at here and hope you understood what are all the things which I have discussed till now. And now let us look at few references. You can go through this. Physical Chemistry by Ball and Ball, Physical Chemistry by Puri Sharma Patania, Physical Chemistry by KL Kapoor, and textbook on reaction chemical kinetics and reaction dynamics by Upadhyay and Santosh, and Physical Chemistry by Negi, and Chemical Kinetics by Leidler, and Introduction to Chemical Kinetics by Margaret Robson Wright, and Chemical Kinetics and Chemical Reactions by S.K. Jain. So all these books are very good books. You can go through these textbooks for the detailed explanation about the chemical kinetics. So dear students, let me stop it here, and thank you very much for watching this video. We shall meet again in the next video, where I'll going to discuss about the next part of the chemical kinetics, where I'll going to discuss about the second order reaction rate constant when two reactants are different. Okay, thank you very much.